Hello scientists! In this video we will look at the ingredients that it takes to make a storm and exactly how to put all those ingredients together to make a storm. In the end we will draw a storm model. Okay, let's go. The ingredients for a storm include unstable air, moisture, energy, and lift. You may have already figured out it's the sun that gives the atmosphere its energy. But what does this energy do? Well, the energy causes water to evaporate, increasing the humidity in the air. It also causes the uneven heating of Earth's surfaces, resulting in air pressure differences. So, how does the sun's energy provide moisture to the atmosphere? Well, it's through a process called evaporation. So the sun shines onto any liquid water, whether it's a puddle or the ocean, a lake, and its energy causes the molecules in the liquid water at the surface to then move more quickly, which then causes the liquid water to turn into water vapor and rise. Now, as it rises through the atmosphere, we know that the upper levels of the atmosphere are cooler, and it causes them to condense. Now, condensation means that it has to condense onto something. So what does the water vapor condense onto that's in the atmosphere? Well, it condenses on dust. It can be dust particles, pollen, dirt, pollution, anything that's in the atmosphere that water vapor can condense onto. Condensation means turning from the water vapor to liquid water. This liquid water is condensed on the dust, and when enough liquid particles or liquid water come together, they form a cloud droplet. And many cloud droplets form a cloud. Now remember, energy is never lost. It is only transferred to something else or transformed into a new kind of energy. So when this condensation occurs, the thermal energy from the water vapor is transferred to the atmosphere. So as this process is happening, thermal energy is being given off into the atmosphere. This also gives the atmosphere energy. One of the other ingredients for a thunderstorm to form is that it has to form in unstable air. So what's the difference between stable and unstable air masses? Well, if an air mass is stable, then its temperatures are going to be similar and its humidity is going to be less. In unstable air masses, the temperatures are going to be very different and the humidity is going to be very high. We actually took a look at this when we watched the video on the demonstration with the cups with the different colored water. When the colored water was similar in temperature, the water mixed together pretty easily. On the other hand, when they were very different temperatures, then they did not mix. The warm air tried to stay on the top and the cold air stayed on the bottom. So what does this mean? Okay, so let's give an example. So let's say in this stable air, all right, let's say it has an air mass with 50 degrees and has some humidity that's at 65%. And the slightly warmer side has a temperature of 55 and humidity at 67%. Not that much of a difference. So if this were actually a front coming through, then you see that it would mix pretty easily and you wouldn't have that severe weather. On the other hand, if you have, let's say on the cold side, let's say you have 62 degrees Fahrenheit and your humidity is 50%, but on the opposite side of that, your temperature is 80 degrees and you have a percent of humidity at 87%. Now you can see this is much greater difference, and therefore as the front moves through, the air masses are going to act more like the people fighting, and they are going to give you more severe weather. So let's review. What are the conditions that are needed for a storm to form? Humidity must be high, and the temperatures must be very different. So very cold air mass and a very warm air mass. Please answer these 4 questions before moving on to the next page. Pause, and once you have answered the questions, then start the video again. You will be drawing a model of a storm forming.